click for that. And so all my subscribers will also get a notification that I'm going live.
Awesome sauce. So everyone, please be on your best behavior. We are being recorded live.
All right, I'd like to welcome everybody. Thanks for joining us. Welcome Mr. Brown and all the faculty, including administrative staff. Thanks for joining, Ms. Wade. There were a few engineering students that joined earlier, hoping that they can come back because there's a little miscommunication with the time. But we're going to get started. So we know it's time sensitive. There'll be a recording, so we'll broadcast the recording, have the full effect afterwards. So I want to welcome everyone to this presentation. Ms. Paul presented at the International Scientific Conference, or the International Research Conference put on by the International Scientific Committee. It was held in Bangkok, Thailand, and from comments and feedback, she did quite well. So we want to send a message across, encourage further research, encourage research in the department and in the school, in the faculty. And Miss Ashley Hall is such a fine example that we wanted to capture the moment. We were unable to on the day because of restrictions by the coordinators of the conference. And so we're gathered here today for that. She'll be presenting on a green industry approach towards sustainable developing economies, material recovery facility. The research was a major project that was done last year. It has been featured at 2 conferences now, so it's really having far-reaching effects globally. And we are very proud of Ms. Hall. And so Ms. Hall, as one of our top industrial engineering students, please take the floor. You have been given co-host rights, so you can start presenting now.
Okay. Afternoon, everyone. Thank you. I'm just going to share my screen. Are you seeing my screen?
Yes.
Yes? Okay, great. So, good day again, everyone. So I'll be doing the same presentation I did in Thailand. My name is Ashley Hall, and my team members include the man himself, Sean Vassell, Michael James, and my supervisor, Dr. Gayman Graham. Our topic today was a green industry approach towards a sustainable development economy based on a materials recovery facility. At this time, we're going to go through the overview of the presentation, starting with objectives of the study, definition of key terms, background, methodology, results and analysis, recommendation, and final conclusion. The objectives of this research was to design an MRF with a facility planning approach with the goal to aid the green economy. More specifically, to propose a location and layout of an MRF, to design the design capacity. A few key terms include MRF, which is a material recovery facility. This is a plant that separates and prepares single-stream recycling materials to be sold to end buyers. Economics of scale, the cost advantages that businesses get as a result of their size, which is normally quantified by the amount of production generated. SIDS, small island developing states. These are a group of developing countries which tend to share similar sustainable development challenges. Climate change for SIDS, particularly in equatorial countries like Jamaica, presents its own set of risks from rising sea levels, increasing temperatures. This impacts biodiversity and human habitat, flora, fauna, and the blue economy. To address development in any meaningful way, consideration must be made to establish these forward and backward linkages between sectors. Many modeling development using the engineering economics, the primary variable to analyze the economic factors, and in subsequent steps, non-economic factors such as environmental, cultural, and social. SIDs are impacted by issues regarding the depletion of natural resources by way of mining for primary production, urbanization, industrialization, water and air pollution, and manufacturing in respect to the environment. In a voluntary national review on the Sustainable Development Goals for Jamaica's Vision 2030, which we're not far off from, waste management has presented an ongoing challenge for urban centers, according to the Planning Institute of Jamaica. The National Solid Waste Authority has been operating only as a waste disposal entity and does not promote environmental or economic growth. Researchers remarked that a materials recovery facility as a solid waste management plant that produces recyclable materials to sell to manufacturers as raw materials for repurposing could be the best option going forward. Looking more closely at Jamaica's current solid waste management situation, we produced over 1.3 million tons annually, and that was just in 2012, so you can only imagine the data now. 70% of the collected waste 70% of the waste generated is collected by the Waste Management Authority, but less than 50% of Jamaicans receive regular collection services annually. And 30% of Jamaican population is guilty of burning garbages, while 300,000 tons of 300,000 tons are disposed of illegally. In the current major dump sites, there are reported of 415 fires, and that's just reported in 2016. While conducting the economic analysis, the construction cost simulation and interval prediction was based on average capital cost and design capacity by Chang and Wang. On the other hand, the operating cost simulation and interval prediction was based on the average annual operating cost and actual throughput by the same authors. Based on the graph, economics of scale was achieved. Our methodology was primarily based on the 7 steps of engineering economic analysis. These include problem identification and scope, cost collection of relevant and available data, and defining the variable solution alternatives, making realistic cash flows estimates, identify the economic measure of worth criterion for decision making. This was grounded based on the seminal research of Chang and Wang cost-benefit analysis, evaluate each alternatives considering non-economic factors, recommend best alternatives, and a pilot plan was recommended for the final steps. Step 1 was determining objectives previously stated. Step 2, while collecting relevant and available data. During the literature review, most authors agreed on 1, labor and access to supplies and raw materials for future expansion. 2, proximity to markets and logistics. 3, transportation and the cost of utilities, as these are the most important factors while determining the facility location. The 4 dots seen currently on the map of Jamaica represents the location that meets these criteria. The dot circled in red was the best site based on the center of gravity calculation. The layout was initially started from the research of literature review. This affinity chart was developed based on the necessary departments required by the MRF. The relation was based on factors, for example, noise level, safety, ease of access, and reduction of cross-contamination. The frontier chart was based on the affinity chart and also color-coded. For ease of readability to create the layout diagram, the relationship diagram was also created. This left us with several space relationship diagrams, and these were the best modules selected. Another one of our objectives was to determine the design capacity. This was based on the forecasted population growth and correlation to waste generation. Assuming all recoverable waste from the Waste Management Authority in a year can be transported to the proposed location of the MRF, and then the facility must be able to produce 1,200 tons per day while operating 6 days weekly. The average MRF, however, operates 80% below design capacity. Therefore, with some recalculation, the design capacity would be 1,275 tons per day. The estimated cost of the MRF was based on values from 1992. Thus, inflation was accounted for. Highlighted is the average construction cost of 15 million USDs, and the average operating cost was 3,360 USD per day. On to step 3. This graph displays a realistic cash flow of the MRF. The cumulative profit of the proposed MRF based on 2018 prices of recycled material was calculated as both the steady price and overall price for inflation. Inflation was estimated to be about 15%. The fourth step, which is the identification of economic measure of worth criteria for decision making. The overall consequences of the Jamaican economy, the impact on employment rates, and the cost benefit ratio for each alternative will be used to guide the decision making process. We came up with 3 main alternatives. First was to do nothing, meaning to stick with Jamaica's current approach to gathering garbage and dumping it. Second was to convert the main dump site into a functional landfill. Third was to implement the MRF, which is our approach. The MRF had the highest capital investments of $15.8 million, while it had the lowest operating cost. While remaining on the current path proves to be more expensive, as seen in the operational cost and total cost. The same comparison was done for the cost-benefit ratio, Jamaica's economic growth, and creation of new jobs across the economy, with implementation of an MRF being the obvious option. Continuing on the path of selecting the best alternatives, while going through the research process, the 3 modules were obtained as previously stated, and this was the best layout proposed for the MRF. While going through the research process, we came up with a few recommendations, but these were the main 2. Updating the National Current Solid Waste Authority Act to prioritize recycling. The current policy does not address the practice of recycling. There are no provisions in place to state which rules or procedures should be followed. As a result, there's no improvement in the way solid management or solid waste should be treated because recycling is not highlighted or prioritized by the necessary authorities. Second, a domestic trade policy, while using MRF as an anchor point, needs to be established. In achieving greening the supply chains, the forward aspect of the cross-sector linked industry requires similar business-to-business collaboration supported by government policies to further encourage strategic collaboration on greening the economy forward linkages in the supply chain. This would expand the productive base and increase the participants in the economy for future expansion. Concluding, Jamaica would benefit tremendously from adopting the green industrialization approach. This approach has a high ability to accelerate the protection and recovery from shocks from climate change while providing a basis for broadening the industrialization potential of the economy. This is more poignant considering the climate change and Jamaica's post-colonial and post-independence dismal growth trends. The theoretical approach for establishing the linkages and broadening the productive base is to further be guided by development of policy and practice in implementation. Now we'll pause for a short video.
Based on a recent study, an MRF with a design capacity of 1,275 tons per day and an actual throughput of 120 tons per day would directly employ 218 Jamaicans. The study also estimated that an annual revenue of 408 million Jamaican dollars can be generated, and this is compared to the NSWMA own source revenue of 530 million Jamaican dollars. This represents only 23% difference. This translates to a productivity of Jamaican $1.8 million per employee if an MRF is implemented. When added to the NSWMA's portfolio, the MRF would improve the productivity of the entity by 68% to Jamaican $0.2 million per employee. This is, of course, using absolute values. These figures illustrate the level of impact that an MRF can have not just on revenues, but also on productivity. Additionally, further research shows that an average MRF can produce 245 tons per day of throughput at a 65,400 square foot plant with just 27 sorters. This results in productivity of 9.8 tons per employee. And as you can see, the output outweighs and shows benefits compared to the input. The implementation of an MRF would contribute Jamaica $3.7 billion to the growth of the Jamaican economy and cumulatively break even in 9 years. This while creating 1,572 new jobs. This is not limited to the possible opportunities that are also created. In addition, an MRF contributes to social and environmental benefits, which include the improved social status of new employees, community involvement in recycling and recovery, lower water consumption in waste management, no gas or odor or dust emission, and no substance emission. These benefits position an MRF as the top choice to choose in improving Jamaica's productivity.
Continuing with the presentation. So just to conclude a little bit, these were the references used within the presentation. And thank you so much for your time. Any questions or comments? Hello, are you hearing me?
Yes, we're hearing you,
Okay,
Ashley.
great.
So we're taking questions now, right?
All right.
So you can just raise your hands if you want to ask a question. All right, in the meantime, there is also going to be a newspaper article coming up. So you could also read further about the material recovery facility and the effect on the Jamaican economy. And I am now going to, while you think of your questions, ask Dr. Graham to approach us. No?
Yes, I'm here. Good afternoon, participants. And I want to take the opportunity to again congratulate the team leader, Ashley Hall, along with the members of the team, Damani, Sean, and Michael, who did excellent work last year in preparing their research. We have a few students here online, and we would have hoped to have some more participation. Unfortunately, our head of school was not able to join, who would have also played a hand in teaching the students that did this project. But I want to just highlight the work, and what made the research so interesting is, it was a difficult problem. It required some research, and there were some challenges. I know Michael has come on And perhaps, Michael, as part of that, you want to just say what were some of the challenges you identified in the middle of the research and how you responded. And I want to also take the opportunity to suggest to some of you who are in second or third year, even final year now, thinking about how you are preparing your project. Every single piece of work that you do relating to research gives you an opportunity to publish, right? And as a practitioner, publication is very good, whether you publish a newspaper article, a blog, or in a journal. In the case of this research, the students have done well to not only present at our UTech major conference project, but 2 other international conferences, which is commendable. And that is a standard that I would like to encourage on behalf of not only the Department of Mechanical and Industrial Engineering, but also the School of Engineering. We would like to encourage students to put yourself in a position to use the biggest platforms that are available to demonstrate to the world that you here at UTech are thinking about some of the world's biggest problems and are presenting ways in which you can solve them. Finally, I'd like to just say that one of the biggest challenges we have in Jamaica is our decrease in productivity over the last 50 years. And we need to look out for projects like this that give us an opportunity to improve productivity while also addressing some of the other challenges that we have in bringing about improved economic prosperity. Certainly climate change is with us, and so this project is very timely. I'm looking forward to continuing to work with Ashley and the team in conducting further research, and I hope certainly that we will move to more concrete steps in terms of a pilot study, have more conversations with the government and private sector interests who would seek to put it in place. So again, that's my bit of comments on behalf of not just the department, but the School of Engineering here at UTech. And, hearty congratulations again to the team. Opening the floor now for Michael to respond, Mr. Carvey. Thanks.
Okay.
Thanks, Dr. Graham. Thanks, Sir Cargill. Just want to tell you, well, a big thank you for your roles in helping us to actually complete the project. Your question about the challenges, my God, they were a lot. Just finding the information that was very tough. Finding credible sources and knowing how you're very tough on the whole reference list and stuff. It was very difficult, but with your guidance, honestly, it made it easier. Thankfully, the team was very cooperative. We all wanted to achieve the same thing. We knew that if we presented a good research paper, then we could basically, immortalize our names becoming published. So that was really what kept us going, even outside of completing the major project research and then, going for these different conferences. So, thank you for even introducing us to some of these conferences. We really owe you a lot. Thanks again.
All right, thank you, Michael. Thank you for those words. I am also seeing the GIE Tech. I am wondering if that is Sir Joseph, and if he could just say a couple words, if that's him, on the research portfolio or agenda for the School of Engineering. In the meantime, if you have any questions, you can raise your hand. You want to hear anything even about research and avenues for research in the school, or general questions about research? We'll take those questions as well.
I know it's impromptu, but perhaps Mr. Cargill, you could share some of the research topics that we have in the industrial department, and I will also share some of the ones in the mechanical as well, and some of our other research projects that we are working across the school with. You want me to go first?
I'll go first, and then
You go
turn
first.
it over to you. For the industrial project department, right now we have 4 major projects, 4 solid topics. One features forming some type of modeling using operations research for the Jamaican health sector, looking at hospitals and how they process patients and so on. Another features designing a biodegradable single-use mask from organic material. That group there is looking at an experiment to test the mask to make sure that they're up to the right standard and that the design and process is sound in creating this mask. There's also a group looking at creating a manufacturing work cell for fittings and fixtures that are imported to the country. So that's another significant project. And then a group that's looking at the operations of the admissions office of the University of Technology Jamaica and how we can increase the productivity and efficiency of that office. Over to you, Dr. Graham. Dr. Graham? Yeah, so certainly we have some
Yes,
good
I'm
projects
here.
coming
I'm here.
up.
Sorry.
We're hoping,
Sorry.
we're hoping that all of those projects
Yes,
can
I'm
be
here.
published, and as long as the students put in the work, there are 4 solid topics. As long as they put in the work, they can be published and go on to present at conferences like the 2 that this paper featured in. Yeah, go ahead, Dr. Graham.
Yeah, man. So we have research in the mechanical department.
I think we lost you there a bit, Dr. Graham. And you're muted. So I'll give you a second there, and I'm just going to...
Are you hearing me?
We're hearing you now. Go ahead.
Oh, sorry about that. Right. So we have topics that include the analysis of a solar-powered pump system, design and build of a flywheel battery, the use of finite state machine method to build a controller for a block making machine, investigations of commercial application of VAWT, development of maintenance program for thermal fluids lab using reliability-centered maintenance approach, design and build of an oxygen concentrator, improving heat transfer rate in a multi-cylinder engine, design and build of an RO water treatment system, design and build of seed planting robot, and design and build of a lab scale plant incubator. So those are just some of the undergraduate research that is currently underway. Of course, we have postgraduate research, more so on the topics on the mechanical engineering side. We have one student that is currently registered and is on sabbatical. He's also a lecturer, and he's into thermal fluids and thermal and energy. But we also have some upcoming research, doctoral research, that will commence in January around vibration analysis. That's in mechanical, and we also hope to have another doctoral research in the fourth, we call it now, the fifth revolution.
Industrial revolution.
Right, Industry 5.0 and its applications. So those are budding research that we have coming up across the school. Chemical, electrical, and civil. We also have other research that are looking to address some of the nation's needs, particularly in relation to climate change, around improving productivity, around applying Industry 4.0, Industry 5.0 to various processes. And any student that is interested in doing research, we encourage you, not because we are the industrial mechanical department, but if you have an interest and it even bridges across another discipline, there's nothing stopping us from conjoining projects and your supervisors giving you the direction so that you can work on different aspects of the project, because it's research, right? So I want to just say that is encouraged right across the faculty, the school, and indeed the faculty. And there are research grants available that you can apply for as well.
Right, thank you. And I would open that up, or immediate past students can also continue their postgraduate research. So they might not be a part, although would encourage them to enroll in one of our graduate programs if they want to increase their research footprint, to also think of collaborating with us to take on projects. Even it might be the case that they have more time now for research and they want to increase their research so that they can apply in the future for master's and doctoral programs.
I'll go even one step further. I'll go even one step further, Mr. Cargill, to say that we get approached from time to time for industry participants asking for researchers. For example, someone called me just last week asking for us to help design a coconut breaking machine. Now, if we are to wait until next year when we have major projects, the person would be basically waiting for a year and they have a problem now to solve. So some of the times, even with you, if you are now a graduate and you're still working, but you have 20 hours a week or 10 hours a week that you can put to it, there's still an opportunity to do research and to work on projects like that on a consultancy basis. So we're encouraging that as well.
So finally, I'm just going to ask if Mr. Bennett has a few words he wants to say. I'll give him a chance and then we're going to close out. Thank you again, Ashley, for a wonderful presentation. I'll send you the YouTube link afterwards so you can also always have it to share. Mr. Bennett?
Well, just want to say congratulations to the group and well done. All the best.
All right, then, thanks. So with that said, I want to thank everyone, all the participants today, for joining us and for being here to listen to the presentation. And if you want to reach out to us, you can contact me via WhatsApp or give me a call. The number that I use for student engagement is 540-4942, or you can email me at a UTech email, q.cargill@utech.edu.jm, or the email that I also use to communicate with students. All right, so thanks again. And we do hope that you have a wonderful day.
All right. Thank you very much, everyone. Have a good evening.